Hi. So, if you want to understand how games work, or if you're perhaps interested in programming your own games, one topic that's really good to know about is collision algorithms. So, a fundamental part of most games is knowing when one part of the game is touching or colliding with another part of the game. So, in a platformer like Mario, when Mario is touching the ground, stop falling, or a fighting game, when one player's fist is touching another player, subtract the other player's health. Uh, Basically, anytime you're having an interaction between two objects, player, enemy, player, environment, player, a power up, or health pack, anything like that, you want to know when those things are touching. So the way we do that in programming is using a collision algorithm. So I thought what I would do today is cover some basic collision algorithms, specifically for 2D games, and implementing them in P5. And perhaps you can use these to make little games of your own, or they might even come in handy for later assignments. So let's get started. So while theoretically it would be possible to write collision algorithms which use exact representations of our game objects, doing so is usually computationally too intensive for the purposes of games. We need to be testing, usually in a game, every frame. We're testing whether the objects are colliding, and we could be testing thousands of objects against each other. So doing so with exact representations would take too long for something that we need to be doing every frame. Also, with the speed that games move at, a player's not going to notice if those collisions aren't being measured perfectly. If the game thinks something's collided with another thing and it's not perfectly touching but very, very close, the interaction is over so quickly that the player's not gonna notice the small imperfections there. So we use hitboxes. Hitbox just a abstract representation of the player. I've got a little demo here, and we're using rectangles as our hitboxes. What I'm going to show you now is what I think is probably the most intuitive, the simplest collision algorithm to learn about. It's called axis-aligned bounding boxes. All that means is it works for rectangles, and those rectangles can be any size and shape as long as they're aligned on the same coordinate system, which is great because we've got Rect Function in P5.js, and that's exactly what that is. So we can use that, which you've already learned. So I've just written a little sketch here. Just got a bunch of variables because we're going to be using these variables to test our collisions. I've made variables for the x and y coordinate of the player, this blue rectangle, which I'm calling the enemy, the player's the green one, and a variable that is going to be true if they're touching, false if they're not. So what I've done is I've written out kind of the scaffold here, where I'm drawing this player at mouse XY, drawing this enemy, and at the moment is touching is false, but if is touching is true, the player will be red. If it's not, it's green. At the moment, always green, because is touching is always false. So how can we determine if the player is touching the enemy? Well, you can think of it kind of like if the right edge of the player is exceeding the left edge of the enemy, but the left edge of the player hasn't exceeded the right edge of the enemy. So if it's between here and here, it would be touching, or it would be parallel to the enemy. But let's do that first, and then we can talk about dealing with that parallel case. So what did I just say? I said if the right edge of the player is exceeding the left edge of the enemy. So let's replace. So this is a good technique, by the way. If you know how to do 90% of your program, write that 90%, and then we can leave a little. Just we're going to be doing something later, but for now we'll just do is touching is false, and then we can come back in, and once we know how to do that, we can write that out. So is the player touching the enemy? If the right edge of the player, so if the recalling that in P5JS by default, which is I'm just using the default rect mode here, the XY coordinate is the top left of the rectangle, and then we draw width and height, the other two parameters here. So we've got player X, so we want the right edge, so we want player X plus the width, player width. That'll give us the X value of the right edge of the player. So if the right edge of the player has exceeded is greater than the left edge of the enemy, so enemy X is the left edge of the enemy, because that's the X coordinate of that top left corner of the enemy there. So if we've exceeded, then is touching is true. Otherwise, else, is touching is false. Let's see what that looks like. Ah, cool. So you can see that when the player has horizontally exceeded the enemy, now our program thinks it's touching. So we also want to test that we haven't gone too far. So the left edge of the player is still has not yet exceeded the right edge of the enemy. So let's just add another test here that also needs to be true for this if statement to be true. So if the right edge of the player, so that'll just be player X, and we want to know that that's less than the right edge of the enemy. So enemy X plus enemy width. So kind of like the reverse of that first test there. So now you can see when the right edge is exceeding the left edge and the left edge has not yet exceeded the right edge, then we're touching. But what that means though is, because we're not testing anything about the Y values or the height, when we're parallel above or below the enemy, the program thinks they're touching. So we've got to fix that up too. So let's add another statement. So similarly to the first two statements, what we want to do to prevent it from thinking that we're touching when we're here is we want to check that the bottom edge of the player has exceeded the top edge of the enemy, because that's not true here, but it's true there. So we want to know that the bottom edge of the player has exceeded the top of the enemy. So the bottom edge of the player will be player Y plus the player height. Remembering again that the player XY coordinate is the top left of the rectangle, and that's got to be greater than the enemy Y. Let's test that as well. So you can see here, so we're not touching, and we're touching. So now we're not touching as long as we're on the left, right, or above, but if we're below, we're still touching. So we got to fix that. So we want to know that the top edge of the player hasn't exceeded the bottom edge of the enemy. So the top edge of the player is player Y, and that's got to be less than the enemy Y plus the enemy height. Great. So with these 4 conditions, if all of these conditions are true, then this rectangle and that rectangle are colliding. They're sharing the same space, they're touching. So another collision algorithm which is relatively simple is this one, which is two circles. So to determine when two circles are colliding, you'll recall from high school coordinate geometry, there's a formula for distance. So if we know the x and y coordinates of this circle and that circle, and we know the radius of each circle, then the circles must be touching if the distance between the centers of the circles is less than the combined radius of each circle. So, distance formula, right? You'll have to forgive me, I'm typing around my microphone here. So there is this distance formula. So the distance is the square root of the sum of x2 minus x1 squared and y2 minus y1 squared, x and y of each term. So we could type all this out. There's even square and square root functions we can use. But you don't need to, because in P5, go back to the reference, we've actually got dist. So dist is just a function which implements that formula. So it will take in 4 parameters, x and y coordinates of 2 points, and return the distance between those points. So the first thing we want to do is get rid of that. Same setup, by the way, as last time. We've got x and y of both the player and the enemy, and this time though we just have radius for each one rather than width and height, because the circle takes x and y and the diameter, so I need to, my code is lying, I need to radius times 2 here. One sec. Okay, so circle function takes x and y and the diameter, which is 2 times the radius. All good. So first let's do the combined radius, which is the enemy radius plus the player radius, and the distance between the centers of the circle is going to be dist. Let's double check that reference again. So we've got x, y, x, y. So replace that with player x, player y, enemy x, and enemy y. And so if the distance is less than the combined radius, that's what I was saying before, right? Then those two circles are touching. Touching is true. Otherwise, x. Oh dear. Otherwise, is touching is false. Let's run that. Perfect. You can definitely imagine something like the game Asteroids. This would be great for, because you've got roughly circular objects in that, and you can relatively accurately determine where they're touching with some quite simple code. So from this point here, I just want to show you how we can start adding some small behaviors and getting a little bit of gameplay that we can experiment with. So let's start with the score. That's a good place to start. So I'll just do let score equals 0, something like that. And then let's make everything a little bit smaller. Half the size, maybe like quarter the size, and then really small. What does that look like? Yeah, something like this. And let's draw the score to the screen. So, don't know if you've seen it yet, but there's a function called text. So we can say text, and we just want to put the score, and we'll put that at 1010 in the top corner, and just do a quick fill 255, make it white. What does that look like? 0. That's a bit high, maybe. Is that 1010 is quite high actually. Let's make it like 50-50. How's that? 0. Sure, that's fine. And let's say when you touch the enemy, let's make a new character. Let's call it food. So same as all the other things, we have same settings there, and then let's make the food the same as the enemy in starting. Actually, yeah, so let's make both of these random positions. So random width and random height. So this will just place both of these characters in a random position on the screen. And food needs a radius as well. Doesn't work in the P5 editor. So we do food radius is 10. That's right. And let's make some changes here. So let's make the players always going to be blue. So where do I do the enemy fill? 200 in blue. Yeah. So let's switch the colors up. So let's make the player. It's going to be blue. The player's not going to change color when we touch the enemy. The food I'll make green, and the enemy I'll make red, so that they're easy to see. So draw enemy, and then we just need the same sort of thing, but draw food. And food is going to be green, so 200 there, and we need to use the food variables. It should be right. So each time I run it, they'll be in different random places on the screen. Looks good. Let's make sure they're not too far off the edge. So to do that, I could just do random from, let's just put 20 to height or width minus 20. So that should keep them in. Just messing around here, so not using a lot of variables for things like spacing. Obviously, if we were doing this properly, we would make that a variable, but let's not worry about that for now. We're just playing around. So let's make it, if you touch either the food or the enemy, they appear in a new place. So at the moment, I'm just doing is touching as the enemy. So let's call that is touching. Let's replace that with is touching enemy. And let's make a new variable called is touching food. Later you're going to learn about object-oriented design, and that makes doing this sort of repetitive stuff a bit easier. But we've only got 2 things here, so it's not too much to worry about. So if we're touching the enemy, is the player touching the enemy? So that's that. Draw enemy, draw food. Okay, so let's add another check for is the player touching the food. Combine radius, distance, combine radius. Let's call these enemy. Combine radius, distance, combine radius. Call these food. Make those food related. Food radius we want instead of enemy radius, and we're looking for the distance between the player and the food. And let's just print that out and make sure that that is working. So print is touching enemy plus what I mean is that plus is touching enemy. So this is just a way to do the string, the line of text is touching enemy, and then adding, so appending in this case, not mathematical addition, appending that. So I'll have labels for my variables. That's all I'm doing here. So we can do is touching food. Is touching food. Is touching enemy is false. Is touching food is false. Is touching food. Is touching enemy. So you see it in the console down here. It's all working. That's all good. So get rid of that for now because it's all working. So we're not doing that anymore. If touching enemy, subtract point. If touching food, add point. That's what we want to do. So if it's touching enemy, what did I call it? Score. Let's see if touching. So we want score minus, and then if touching food, score plus, and if is touching enemy or is touching food, enemy x equals random. What did we do before? So we'll just do that again. I'll just copy paste it for now. Obviously it would be better to abstract that out into a function now, but just get something quickly up on the screen. Alright, so if I touch the food I get a point and they go up. But if I touch the enemy, I lose points. Very easy game. One thing I could do is I could increase the player size. So I don't know if you played Snake or Agario, that's a more recent one. So I could just do a player, what's the radius? Let's add 10. So this way the game gets a bit harder as you gain points, because you're really big and you gotta be, but eventually you gotta get to a point where you're just gonna win. So that's another condition we could add. But yeah, you can see how easy it can be to prototype little little games like this. Simple as it might be, this took all of 10 minutes. So yeah, interested to see if you guys are making games, what you come up with, and if you're interested in learning more about collision algorithms or games in general, let me know, and we can do more videos on the topic. So thanks for watching.